Hi students, today we're going to go through the final question of tutorial session 4, and the question is, this is the opportunity for you to see how all the math that you've learned in the first few slides apply to the human body. So if we look at the question requires you to work out the effect of the ground reaction force on each joint in the lower limb. So schematically drawn, this is your hip joint, this is the thigh, this is your knee joint, this is the leg, the ankle joint, and the foot. This is the ground, and as the heel hits the ground, it exerts a force on the ground. So if we recall Newton's third law, every force has an equal and opposite reaction. So this is the ground reaction force of the ground against the foot. So let's look at what the ground reaction force is going to do to the ankle to start with. So we know that this is the ankle joint, and we know that the ankle joint can dorsiflex and plantarflex. So if we look at the ground reaction force, it acts on the heel and it's going upwards. So with every force, we have to first resolve it into its two components, which is the vertical component as well as the horizontal component. So for this ground reaction force, this is the vertical component, and this is the horizontal component. Right, so because forces are vectors, the length of the line that you draw is also a representation of its magnitudes, or how large the force is. So you can see that with this force acting upwards on the heel, this is going to have an effect this way on the ankle joint. So it's going to move this part of the heel upwards, and the horizontal component is going to move the heel backwards. So these two forces together will work to rotate the ankle joint this way, and if we move it 360 degrees, we can see that the action is to finally plantarflex the ankle joint. Okay, so the next thing we want to look at is the effect on the knee joint. And if you remember from our lecture, if the force is acting across the joint itself, or if you remember on the seesaw, if it's the fulcrum, then that force has got no effect on the joint. So in this case, the ground reaction force will have no net turning moment on the knee joint. Okay. However, let's look at the hip. So we know that this is the hip joint, and this is your thigh or your femur, and your hip joint can either flex or extend. So if it's going to flex, it's going to turn this way, and if it's going to extend, it will go this way, right? So let's look at the effect of the ground reaction force on the femur. So if you look at the ground reaction force here, we can again resolve it in its two components. So we've got the vertical component as well as the horizontal component. So what is this force going to do to the thigh if the hip joint can't move, right? So if you look at the vertical component is going to move the thigh upwards, so it's going to flex the hip joint. The horizontal component is going to move the thigh downwards and backwards, so it's going to extend the hip joint. All right, so if there's a force that's going to flex the hip joint and there's a force that's going to extend the hip joint, which way will the hip go? So that's where we start looking at the magnitude of the force. So you can see here that the vertical component of the force is a lot larger than the horizontal component. So in this case, there will be a net force. The vertical component will win out, right? So looking at the thigh is going to move upwards because of the vertical component of this force. So it is going to flex the hip joint. Right? So in summary, the ground reaction force on this lower limb is that it will flex the hip joint. There will be no effect on the knee joint because it's going through the knee joint itself, and it is going to plantarflex the ankle joint. So this is how you work out the ground reaction force and its effect on the joints in the lower limb.